Okay, so here we have a square, ABCD, a line of reflection, let's call it, I don't know, line M. And we have this point D prime, which we'll get to in a moment. And we're going to do a couple of things here. First, we're going to draw a reflection of this square over line M. So basically, we're going to get a mirror image on the opposite side of the line. So D, since it's on the line already, will stay there on this image over here. So D prime is also on our line. We can label that. This is D prime as well. Or you know what? We shouldn't have two D primes. We have this D prime over here. So let's just we'll leave D as D because it's still the same thing. But where is C, right? Where did it go here? Well, again, a general rule of thumb is that C and C prime are both an equal distance from the line of symmetry. So if I just draw a line here and here, those two distances are equal, right? And they're both perpendicular to the line of symmetry, therefore the corresponding points. So B and B prime is right here. Again, those distances are equal. Right? The line of symmetry is the midpoint between them. And if I draw that line from one to the other, it'll be perpendicular to our line of symmetry. And last we have A and A prime, the same idea. Let's draw a line from one to the other. The line of reflection is exactly halfway between them, and that line that I drew from A to A prime is perpendicular to our line of reflection. And therefore we have constructed a shape that's been reflected off of this line M. If it started as A, B, C, D and became A prime, B prime, C prime, and well, it's still D because it's at the same point. Next, you want to rotate this shape, right, 45 degrees and have A be our point of rotation. So I'm just going to move everything so I have enough room for this. Okay, that should be good. So that means we're rotating about the point A. So it's like our point, if you imagine, that has the pin in it, and we're turning the rest of the shape. So how do we find where things go? Well, all we have to do, and I'll use orange for this next shape, is find 45-degree angles that go from, let's say, B to A to our new point over here. We'll call it B prime. So this is 90, 45 is about half, right? And that's B prime. So we're just drawing 45-degree angles between corresponding points. So B to B prime will go right here, and it's about right because this angle here is 45 degrees. And the distances from B to A and B prime to A have to be equal. It goes back to this idea that when you rotate a point or a shape, every corresponding point is rotating along a circle. So you can imagine that B is floating over to B prime along this circle. So therefore they have to have the same distances. That 45 degrees is 45 degrees of the circular path. So in fact I should make this line a little bit shorter based on that image. Fix that. So let's say about 45 degrees is about here. So that's B prime. And we'll do the same thing for all the other points. A will not move anywhere, it's the center of rotation. But C will go 45 degrees. So instead of being a line here, it's going to move up, right? In fact, our whole shape is now turning. So we have this line right here from A to C, which means 45 degrees, right? It's about up here. So up a line up there points us to C prime. I'm just going to estimate it's about here. And if you're doing this precisely, you can draw or measure the distance from C to A and measure the distance from A to C prime to make sure they're equal. And you can also measure the angle between them. So you draw a line from C to A and from C prime to A and make sure it's 45 degrees. As you can see, this shape is essentially turning, right? And this will go about right here. And we get this square that's now been tilted. And again, from D to A, and this is now D prime up here, right? That angle should also be 45 degrees. I'm just doing a rough sketch, though. You can see it's slightly off. This should look much nicer. But again, you can turn by measuring. And if you're really stuck, every point follows a circular path. So if I go from A to D, you can see how it's off here. D prime should be about here because it should follow the circular path, right, from one corresponding point to the other. And that's just because I estimated over here, and you should not do that if you're trying to answer this exactly. Lastly, we want to imagine that we're translating this square right, the green square from D to D prime, what will it look like when we do that? Remember that translating just means sliding. So our square is now going to be over here. We slide the green square from here to here, and everything is in the same relative spot, right, except it's been shifted over to the right. So A to this spot is A prime, B to over here is B prime, and C leads us to C prime over here. Now, if you're trying to be exact when you're doing this, which you should be when you can, is realize that whatever distance we go from D to D prime, that should be the distance from A to A prime, C to C prime, and B to B prime. All those distances should be identical because we're translating the whole shape, right, in the same direction for the same amount of distance. All right, so I hope this helped.